Hey guys, welcome back to science. Ms. Higgins here. Last time we wrote a scientific explanation of how sound gets from a mother dolphin to her calf underwater. For these next couple lessons, we're going to be switching topics. And Maya Martinez, the superintendent at the park, noticed that when a mother dolphin and her calf are separated, the mother whistles and her calf swims toward her. The scientists also observed that when a mother dolphin whistles, only her own calf swims to her. So we're going to investigate a new question today. How does a dolphin calf know which call is his mother's call? So today our teaching point is that scientists investigate why some sounds are different than other sounds. And to do that, we're going to look at what's called pitch, volume, amplitude, waveform, and wavelength. Don't worry, we're going to learn what all those terms mean today. So first, we're going to go to our sim, but we're going to change to the custom sound mode, and we're going to play around with some sliders at the bottom and see what changes about the sound. One thing we need to know is that a waveform is a curved line that shows the pattern of a wave. So I've switched to the custom sound mode, and now this green line is going to show us the wave form, or what the wave looks like. It'll also record it down here in the wave printout. So let's play a sound and see what happens. Okay, so this is the wave form. This is what the wave looks like, and we have a printout down here. Okay, very cool. Now we have two sliders here, one for amplitude and one for wavelength. Let's see if we can figure out what amplitude is just by playing around with the slider. So let's click play and see what happens when we move this. Do you have a guess what amplitude might be? Let's try that one more time and see if you can figure it out. It seems like amplitude has something to do with volume. When I clicked a small amplitude, the volume got really quiet. But when we clicked large amplitude, it was really loud. And we can see that in the wave printout. When it was really loud, the wave was really tall. When it was really quiet, the wave was really short. So I think amplitude has to do with volume and the height of the wave. All right, let's see if we can figure out what wavelength is by playing around with this bottom slider. Okay, did you figure out what wavelength is? Let's try that one more time to be sure. All right, I think that wavelength has to do with pitch, and pitch is how high or low a sound is. So when there was a long wavelength, the sound was really low. But when there was a short wavelength, the sound was really high. So we can also see that reflected in the wave printout. When it was a short wavelength and really high pitched, the waves were very close together. When it was a long wavelength, a really low, we can see that the waves were very far apart. Okay, I think we figured out amplitude and wavelength. Let's go back to our slideshow and see the answers. Okay, we were correct. Amplitude is the height of a wave, and it's also how big or loud a wave is. So changing the amplitude of the sound wave changes the volume of the sound. And something else you might have noticed from this sim is that the larger the amplitude of a sound wave, the more the particles move. So when something is quiet, they don't move as much as when it is really loud. And then pitch is how low or high a sound is. When we moved the wavelength slider, it changed the pitch of the sound. Wavelength is the distance from one peak of a wave to the next. In other words, it's how close together they are. So we see that these waves are really close together, but these waves over here are really far apart. So we would call that the wavelength. When it was a high-pitched sound, they were close together. When it was a low-pitched sound, the wavelength was really far apart. Now, if you guys have these materials at home, I would love if you could try this experiment. You're going to make a straw reed so you can investigate why some sounds are different than others on your own. So you'll need a straw and you'll need scissors. So if you have those materials, I'm going to show you how we can make a straw reed. First, you're going to use your teeth to flatten one end of the straw, and you'll use scissors to cut both sides of the flat end so it's shaped like a V. You're going to gently pop the end of the straw open. The two V's should be close together but not touching. Then you can put your mouth on the cut end of the straw and blow. What happens when you blow through that straw? What does it sound like? Then you're going to make a modification. You're going to cut about 3 centimeters or 1 inch off the bottom of your straw and observe what happens to the sound. Then I want you to blow again and cut the straw 3 more times. So you're shortening the straw reed instrument. What are you observing as you shorten your reed? And why do you think that some sounds are different from other sounds? So I hope that you have these materials at home and you can pause the video and try this out. What we should have learned today is that when sound waves have different amplitudes, we hear sounds with different volumes. And when sound waves have different wavelengths, we can hear sounds with different pitches. That means high-pitched or low-pitched. So today, your job is to take the Google quiz to test your knowledge on the 5 vocabulary words that we learned today: pitch, volume, amplitude, waveform, and wavelength. You can come back to this video as many times as you need. All the answers are in this video. Then also in the Google quiz, you're going to use what you learned to label the diagram below. So by looking at the wave printout, we have to think, is this part loud, medium, or quiet? And same thing for the other 2 parts. Good luck and happy working. I will see you next time.